Hi, welcome to the podcast. Today we have Chandan Vijay, a global chief data officer with over 21 years of experience in data strategy, analytics, and data transformation. Chandan has led data initiatives at major industrial companies, including GE, Honeywell, and currently at ABB Energy Industries. What makes Chandan perspective unique is his philosophy that data should be treated not as oil but as a nuclear reactor energy source with potential to generate massive insights. We'll explore how organizations can harness data for competitive advantage, drive sustainability, and transform industries. Chandan, welcome to the podcast.
Thank you, Satya.
As we go through, we have been watching it almost 2 years ago, and now you have a fascinating perspective on data, traveling. You have a fascinating perspective on data, treating it not as an oil, but as a nuclear reactor energy source. Can you explain what you mean by this? How does this philosophy change how organizations should be approaching data?
Absolutely, Satya. I think it's a metaphor. When I used this word 2 years back in one of the data analytics conferences, that I treat data as not as oil, but as a nuclear energy source. The way I perceive it is, if we look at oil, right? Oil is a finite material. It's extracted, it's burned, and it's depleted, and it causes smoke, which is carbon emissions, right? Similarly, when you look at nuclear reactors, a small material can generate infinite source of energy, and it produces energy in a very consistent form. Data, in the contrast, is again similar. It is regenerative. It is compounding in nature, and when refined properly, when structured properly, when it has the right context, it can generate immense amount of, I would say, insights. And those insights can be reused, repurposed, blended with other data sources to generate more insights. And I think that is where, if we treat raw data in isolation, it's like oil. But if it's structured, if it is having the right format, it is having the right context, it becomes enriched. It becomes like a nuclear reactor energy source. It can potentially give output which is exponentially greater than what the input is actually. And that is how I say it is a source of energy which is much, much better than oil. Again, in a nuclear reactor, the elements that you put in the uranium-235, if it is in an impure form, it will not generate the same amount of energy when it is in the most enriched form. Similarly, data in its enriched form, in a very governed environment, can give a very insightful information, and it produces the output, or it produces the value of its source into a much, much bigger value. Similarly, when you look at nuclear reactors, right? If not handled properly, it can create chaos and it can create tragedies. Similarly, when data platforms are structured, when they are provided the right governance, when they are having the right guardrails, it can provide, I would say, the insights, it can provide the value to the organization, which is way higher. And therefore, I treat that data as not as oil, but as a nuclear reactor energy source.
Good. So we moved from data being the oil to data being the new soil where we have to nurture, to a nuclear reactor analogy. I mean, one thing I see constantly is that it just not, if properly not handled, it just doesn't hallucinate like AI, but it can explode. So I get that point. So that brings me to the next question. From the data chaos that we have all around us, because in the urge of knowing the data, we collect so many data and stuff like that, and you impressed upon the quality of data also. Many organizations typically struggle with the data silos, and then once the data is accumulated, the poor quality of data that comes in, and also the limited accessibility. I've been hearing you talking about data democratization at the same instance. What does that actually mean, and how do you intake data accessible and to both technical and business users without the chaos?
I think data democratization has a very, very wide meaning in terms of when people look at it, right? I think it doesn't mean that we're giving data to everybody. Data democratization in a really good platform means enabling the right data to the right to access to the right people, and they are able to understand it and they are able to use it as a trusted data source. Now, data can be used by different personas, right? So there are technical people who are engineers, data engineers, and then there are people who are analysts, and then there are people like executives or middle level managers. It is all about the understanding the need of the people as to what level of data they need, what granularity of the data they need, and how they want to consume the data. And I think that is where data democratization kind of reduces the chaos when a large amount of data is available in a platform, right? It basically reduces your decision making time, it improves transparency, it improves trust. Now, how do you build on it, right? You basically allow the teams to access data, or you allow different domain structured or function structured people to access the data basis of the need that they have and not beyond it. So it's enabling data for their needs in the respective KPIs and the respective, I would say, operational efficiency that they need to want to build using that data. Now, again, when I come back to the personas, right? There are executives who need data in a more, I would say, structured format in the KPIs, right? How do you enable those kind of data sets that is accessible to executives only and which give them the relevant information? The middle level managers need some more insights about it, that they need a slightly granular level of data more than what executives need. So they're able to understand that and they're able to give answers back to the executives when the questions are answered. So when we look at those different personas, when we look at analyst as a persona, you build domain specific, you build persona specific data sets, you curate them, you refine them, and you make people trust in them by enabling it in such a way that they are able to access it in the fastest possible way, and it gives them the right information. And that is how the data democratization kind of is achieved, with the different personas, with the different domains, different functions, and giving auxiliary, I would say, rights and privileges in the system so that they are able to understand the data. The last piece which I talk about in data, I would say, democratization is the data literacy, making sure people understand what data they need. So how do you treat data literacy among users, that they're able to understand what they need, where they need, and how can they access it? And that is what makes data democratization, I would say, a transformative initiative in all data platforms, because it enables the end users and it enables the technical users to look at data differently and get the right data in the fastest possible way, and therefore creating a shared enterprise vision of leveraging data within the organization. That is how I would say a data democratization would create a data as an asset rather than making it as a fragmented, I would say, artifact, which is all over the company.
Sure. So from breaking the silos to getting the quality of data organized for the right people at the right time at the scale that they require, provided they should be able to also trust the data and know the literacy around what kind of data that they seek. Amazing flow of the experience that's coming out. Thanks for that. Now we'll slightly take on a level up from the data to, we have been hearing AI doing a lot of things around the data. And then we'll just hover upon AI data convergence, why both matters. You said without data, AI existence is questionable, and without AI, data cannot be leveraged at scale. Can you unpack this for our viewers? How should organizations think about the relationship between the data and the AI?
Absolutely. I think I said that again a couple of months back, and I would reiterate that without data, I think AI is nothing. And without AI, the kind of data that systems are generating today, it cannot be fathomed to be understandable and interpretable by human mind in the most straightforward ways. I think it's a very, very tightly knit relationship that data and AI have it together. Data is what is, I would say, a critical element that gives AI its meaning. And without AI, I think, as I said, we are generating so much large amounts of tranches of data that its value cannot be accomplished. Today, the latest models learn patterns. They're able to basically understand relationships. They're able to identify anomalies and behaviors within data, whether it's human behavior, whether it's even animal behavior, whether it's weather patterns, whether it's energy generations. This high amount of volume of generation of data and the contextual richness can only be accomplished by AI models. Imagine a simple plain taking a flight of 2 hours. An aircraft typically would have more than over 4,000 sensors, which are generating immense amount of data when the flight is taking straight. In those 2 hours, it will generate terabytes and terabytes of data. Now, if it's given to a person, first of all, they will not be able to put the data in a format where they can actually understand it contextually. Even to hold the data in a system would become a challenge for that person, right? That is where I think AI comes in. It understands the overall context. It understands how to, I would say, synergize the data and link it together and generate insights at a speed, at a velocity, which is not fathomed by a human mind. And I think that is beyond human capabilities to even converge that and produce those outputs in that way. So I think data and AI are a very, very complementary, I would say, components of a modern data platform, a modern data system. That is what creates an enterprise asset. We have very clear data pipelines today, which are feeding data. Like you have the point of sale systems across stores in the world. We have, I would say, the asset performance management systems, which are monitoring energy consumptions and productions across the grids. And those systems, they are being run by AI, and they are discovering hidden patterns, and they're discovering information which was not easily understandable by people. And they're able to correlate those different anomalies or patterns to give, I would say, the newer insights, which generates the newer avenues of value creation. And that is where I think data and AI kind of come in as a complementary set with each other, where AI-driven decision making is an engine which is supported by the large amount of data that's available. And that's what I would at least close this question, answer this, that measurable gains from using data can be accomplished by using AI, and especially with the large amount of data sets that we have. So in this, I would say, complementary relationship, they both exist, and they both need to exist or coexist in a very tightly knit fashion so that organizations can harness this power of data that they're getting and AI to bring value for their customers and consumers.
Sure. I think it's well said. It's not just modernization of applications, but the relationship between data and AI has to be seen in a new modernized version wherein each one complements one another to have that kind of insight generation or any other downstream feed into action or decision making. That's a good one. So now we will move on to generally what is demanded of the industry, particularly around the energy industries that we thrive, which feeds every other system being up and running, is one of the crucial aspects of sustainability. How do we enable sustainability through data-driven decisions is the highlight of it. And organizations are under pressure to meet sustainability as well as their decarbonization goals, even more with the energy industry. How can data and AI actually help achieve these goals in specific? And probably what's the connection between data strategy as well as the sustainability is something that we want to uncover from the background from where you are coming from, which is an energy industry.
Right. I think definitely as part of energy industries, I think one of the biggest things that is there in future looking ways, and even now, sustainability has become a very, very big keyword. I think we all saw Davos videos and basically sessions, and there were two themes which were very clear out of that. One was the sustainability part, and the second was very interesting one, which is everybody started talking about AI and data and how can they help become sustainable organizations. I think data strategy is very, very paramount for bringing sustainability in organizations, because when we talk about, let's say, carbon emissions or decarbonization, and we understand the different elements of basically the whole supply chain and the energy productions and the carbon emissions that it's having. What is the biggest challenge is how do you reduce if you cannot measure it, if we cannot quantify it? And I think that's the biggest challenge the industry as an overall, or our humanity as an overall is working through right now. That how do we look at decarbonization and how do we reduce it, and by measuring it effectively. And I think that is where data platforms kind of come into picture, that when you have a solid data foundation, which is predicting your carbon emissions, which is predicting your carbon accounting, scope 1, scope 2, scope 3 emissions, understand what the baselines are. Without understanding what we are producing and what we are basically, I would say, quantifying what we are producing, we cannot look at what we want to reduce or what the standard should be in next let's say 5 years or 10 years, right? I think if we take an example of a supply chain in a very simple way, if we have a completely threaded data, which is talking about when a product is produced at a supplier and it's shipped to your location, and then you take that product and you build our own product and then you ship it to our customer, and just understand this whole supply chain pipeline and the manufacturing and then shipping and then installation. What is the entire data cycle of this? By combining all this data thread into a single unified platform, by quantifying it, we can understand what is the carbon intensity at a supplier level, at a product manufacturing level, at our site, at a customer facility, and even during those, let's say, transportations and all. This brings in enormous amount of transparency for ESG reporting, for example, or for carbon emissions, right? When we are able to properly quantify it and give a connected threaded data, there is a trust which is established between, let's say, customers, the different stakeholders, the different, I would say, sustainability organizations, and the platform kind of starts to evolve. And then if you take AI into it, right? If we are able to get this into a proper platform, this creates a visibility into your data structures. I think machine learning models can identify patterns about, okay, what is the optimized way of, let's say, shipping a product, or what is the supplier which is having the least amount of carbon emissions when generating something. And I think those are the kind of things that can help reduce the emissions or basically bring in more sustainability in our operations. Again, if we look at the grids, for example, the energy is produced by both the renewable sources as well as the fossil fuels. If we understand what are the cycles where the renewable sources are producing effective and efficient energy more than what a fossil fuel would provide, and it's more than the needed capacity of a system, we can have a better, I would say, handling of the resources within the grid, that let's take energy from renewable sources more and reduce the idle time, or basically reduce the consumption and production from fossil fuels. Therefore, the grid is more effective. The grid is basically, I would say, more sustainable in terms of carbon emissions, in terms of, I would say, ESG monitoring, in terms of basically controls. And I think that is where the entire emissions can be monitored better. And therefore, this data platforms, by tracking all this data and by putting AI on top of it, can actually give you a much more effective and efficient operations in either energy producing industries, energy consumptions, and therefore making the planet more sustainable.
Sure, that's a neat and easy way to put it. What doesn't get measured isn't counted, and particularly the symbiotic relationship between data and AI in the area of where it's not just a compliance on the sustainability and other goals, but it also helps the downstream application of planning better your supply chain, inventories, and also the grid from the aspects of the renewable versus non-renewable. That was a good echo of what's happening and what are all the chief applications where we get immediate value. Thanks for that again. Now we moved on from the data, its symbiotic relationship with AI, and what are all the possibilities. We have addressed the data chaos. Now, what about the systems chaos that we have? We have pretty much in legacy systems and modern solutions, and then we see each one doesn't talk to upfront. So many industries, especially as you know, energy and manufacturing have large legacy systems that spans beyond a decade and so on, with different softwares, hardwares. How do you integrate the modern data and the AI solutions with these legacy systems, and what's the practical roadmap? Because in isolation of a new system, it's very easy as compared to the legacy system. So what is your practical roadmap there?
I mean, very interesting question, and I think this is one of the areas which we are solving very aggressively. We are one of the largest DCS providers, and I'm happy to say we are with the number one organization in terms of distributed control systems. And looking at that and looking at basically what we are trying to solve, I think it's a very apt question, because a lot of industries have these systems which have been running for, let's say, 10 years, 15 years, 20 years, and they're not easy to go and change. A lot of SCADA systems, a lot of PLCs, they're running on legacy databases and on I would say databases which are not really designed for real-time systems. Now, how do we look at that challenge and how do you solve it? I think these systems are mission critical and they cannot be interfered in a way that will bring a downtime. So therefore, how do we bring in, I would say, a real-time analytics on top of it? How do you integrate it with the modern systems and make them more efficient? I think it's about understanding how these systems are currently running and then trying to work through creating different APIs and different systems which can integrate in the older protocols and are able to fetch the data out from those legacy systems into modern cloud. I think using REST APIs, using OPCs, basically MQs, these are the things that we are looking at, that how do we create our abstraction layer, a connectivity, an abstraction layer that can connect to these older systems, extract the data, reduce the latency of that data, apply cybersecurity protocols on that, and be able to get the data into modern cloud systems in a I would say in a more modernized data platform. What does this do is, by creating a middle layer or an abstraction layer which takes out the data and which has a connectivity in there, we can implement the right levels of cybersecurity controls. We can implement the right, I would say, legacy data and bring it into a good abstracted data platform, which is highly scalable, which can provide data virtualization, which can provide streaming capabilities in these different systems. Now the actual SCADA system can continue to work as it's. The abstraction layer or the connectivity layer protects that assets by giving the right level of cybersecurity controls, the zero trust, giving a proper network layer, and still be able to get the data and bring it to a, I would say, modern data platform. And that is where, once you are able to get the data into a data platform, that is where you can bring in your, I would say, OT and IT engineers together to understand how the data should be looked upon. How do we create more AI models on top of it? What can we create? Let's say, for example, how can we create digital twins for doing that? And I think that is where, without disrupting the operations of these legacy platforms, we decouple it, and then we are able to use the data into a platform. Now, even if these legacy systems are not able to give that large amount of data, which is like a streaming data, by putting into a modern data platform, by using AI, we can still create simulation models, we can still create synthetic data, and then support AI training. And I think that is what APMs is a lot about, that how do you have asset, basically preventive maintenance, you have predictive maintenance, you have predictive and prescriptive analytics on top of your systems. And these systems, they need to be built in a modular way. They cannot be created in let's say, in such a way which is a very, very tightly created system, because then the dependency on the solution will be like at a single location. By creating modular, by creating architecture which is scalable, we are able to go and plug it into existing systems without compromising the plant quality, the plant reliability. And by focusing on high value use cases, we create a platform which is a value addition for the customer. We are able to give the customers the insights into their own data and create newer, I would say, avenues of optimizing their operations, making them proficiency gains. How do you make their operations more effective, more cost effective, and by having less downtime, they can actually run their plants and operations in a more effective way. And I think in energy industry, or for example, in any industrial organization, any unplanned downtime is a cost, and nobody wants to lose revenue. And therefore, by creating systems like that, we are able to give them more better insights into their own operations. They can plan effective, I would say, downtimes. They can plan their operations more effectively, and therefore get the revenue out of it and a better ROI by having these scalable systems on top of their legacy platforms. And I think that is what Automation Extended is all about.
So that's a very absolute business perspective. Business cannot wait for AI to come up to speed. So there is no downtime that can be envisaged.
Right.
And we have a legacy system. We have to create the right level of abstraction with a security mindset, and then trying to get the data. And one more point you pondered upon was basically what kind of synthetic data we can use for training versus, while it's actually on production and creating digital twins. So those are definitely some practical approaches. Looks like we hear from you and from many others as to how to go in that stage-wise approach. Now we went from data chaos to AI chaos to something even more important is this organizational chaos. So when
Right.
we are actually building data, integrating the legacy systems and poising it for a future, modernized system. While building this data-centric organization, there is also a parallel organizational transformation that is expected. So creating a truly data-centric organization requires more than a technology, as we see. It requires a cultural change. How do you transform an organization mindset to make the data the focal point of decision making? What does this look like in practice?
Right. And I think you rightly said, right? It's a cultural shift. Traditionally, we've all relied upon our inherited knowledge in an organization. The senior the leaders are, the more experienced they are, it's considered that they have got a lot of knowledge, they've got an understanding of the industry. How does it work? Whereas if we look today how organizations are structured, I think a lot of organizations are becoming data centric, data focused, and it's a cultural shift to move towards that, because it's moving away from in general senses, if I have to call it in a layman's language, right? What do you think to what does our data say? It's a mindset shift from intuition based decisions to what is the story that the data is telling me. So technology, IT enables access to data, but what really changes is the adoption, and that adoption is heavily dependent on the mindset and the cultural adoption of that. And I think it's important that it's considered a very large change when you want to make this as a cultural shift. It's a change, right? And any organization which is moving towards a change, everybody knows change is very difficult to implement in organizations. So I think one of the very first things that goes is, how is the top leaders looking at that change? How are they looking at data? Are they using data to make decisions, or are they still looking at intuitions? Are they asking this question, what is your opinion? What do you think? Versus, what is the KPI telling me? What is my data telling me? How is the sales looking like? Which region is doing better? And understanding these things coming from data, it becomes a starting point for the organization under that leader itself. That how do you do, let's say, discussions with more structured data? How do you have performance reviews, for example, with people, right? How are their reviews being done by data and not just by behavior? How are operations being planned? Are they planned being looking at, seasonal wise, it's going to look like a good season. Can I do this thing versus what's the market really looking like? How is the GDP looking like? Am I looking at something which is going to disrupt the market? Is something going to cause, is inflation going to cause a problem, right? How do you look at all of those and then plan effectively using those data sets or the KPIs in your strategic prioritization? And I think leaders need to bring in this as a behavior in their own ways of working. They ask for metrics, they ask for questions, they ask for basically fact-based accountability rather than intuition-based or behavioral-based. Now, I think when we start treating data as an asset in an organization, executives need to articulate what is the vision that we are looking for data to give us. What KPIs are we showcasing to the organization? How are we building executive scorecards? What is the signals we're giving to the organization? The next step comes as, when a leader looks into it, how are they enabling the organization under them to look at the data? Are we treating and training people to understand data? Are they understanding data literacy, right? Are people skilled enough to understand data? How are we looking at different roles in the organization and making sure that they understand their roles and how data aligns with their roles, right? Finance organization understands how Excel's to be used, or from Excel's, how do they get to dashboards? Or now you have chatbots, right? How do they understand and what questions to ask? Similarly, a plant level persona should be able to understand the operational metrics that are happening in a plant. Is there something which is dashboard telling them that is going to cause a problem? So understanding and creating those data literacy in an organization is equally important from a topmost level to the bottommost level. And then, of course, creating cross-functional collaboration within the organization. Now, a lot of people have functional understanding, like finance people have understanding about how revenue is calculated, how EBITDA is calculated. Bringing in, I would say, data scientists, bringing in the data engineering teams, bringing in analysts who can work with them, and then producing data products creates a culture of basically utilizing data to give decision making tools in terms of people. So I would say, looking at overall as a, I would say, cultural shift, it starts with the topmost leaders and then going down the organization by data literacy, by making people align to the data, by creating structures which are giving data-based or fact-based answers rather than relying on the opinions or thoughts of select few.
Yep, that's well said, Chandan. From the leadership to the data literacy, finally, it boils down to beauty is in the eye of the beholder, but the eye should be through the lens of data. Well said on that. Now, you also mentioned upon the skill gap, not just in terms of data literacy, the talent for a data-driven future, where there are skill gaps in the energy and the industrial sectors. What specific skills are missing, and how should organizations and education institutions address this gap, particularly from the data-driven future that we see?
Right. Very, very valid question. I think if we look at India itself as an example, right? I think everybody wants to go into the computer science. Everybody wants to do engineering. I was in a CXO session yesterday, and we were talking about like the education part itself. And there was a gentleman. He was from again another manufacturing industry. He said we went to a college for basically recruiting talent, and he said I could find like 21 different computer science streams and not a particular industrial manufacturing talent. And I think that's a fundamental gap that we see in our, I would say, education and industry. We have, if we call it now at this point in time, it's an intersection of operational technology and information technology. We are creating a lot of talent which is IT savvy, but we are lacking the talent which is the manufacturing or industry savvy, which are the OT savvy, if I'm to call that way. And I think that's a talent gap I would say we have, that we have got few people in the industrial manufacturing side, and there are more on the IT side. How do we bridge this gap? I think we need to be able to bring people to understand that in terms of IT, OT is equally important. I think when we are going to organizations, the processes in manufacturing, the processes in industries are critical to run their operations. And then therefore creating a cross-functional organizations where there is deep expertise in mechanical, industrial, operational expertise for the processes, in addition to bringing in professionals who bring in the, let's say, the IT, the data analytics, the data science skills, and then kind of creating I would say, a COE or an ecosystem or a pod structure where these two talents work hand in hand to bring, I would say, insights and outcomes which are specific to a domain, specific to an industry, specific to a cycle. And I think when we look at a talent gap, right? How do we train even the OT talent, which is the manufacturing or process talent, to understand data, make them data literate, so that they are able to understand and decipher the data that's coming through the systems, through the connected systems? How do they look at the, I would say, even the SCADA systems and say, okay, I understand how this system works, but what data is it generated? How do I get insights out of it? So by bringing that knowledge to their capabilities, by making them hybrid professionals who understand their core industrial process, but also start to understand how to apply tools like, let's say today is where we're talking about clouds and chat GPTs and all, that using the data, putting into those systems and trying to ask those questions around where do I see a gap or where do I a missing context, and create those contexts and build their knowledge around the OT systems as well as the latest technologies, as well as bringing these IT talent engineers early into the systems and making them understand how does those contextual processes happen in an industry and how do they basically can learn through it. And I think how it starts, the way it can be done is investing in a structured skilling right from the college durations itself or the education itself by creating labs, for example. We do go to a lot of colleges, we provide our equipment, we set up small labs there where the engineers who are doing different work, even in IT, they can go and look at those products and say, how do these products work? What do they do? What can I learn about this and how can I learn to process it? How do I make it more effective? Can I do something around it which will make this product more effective? So by creating, I would say, created labs with educational institutions and the industrial organizations, they can bring in a curriculum change in the organization which can basically be more directed towards talent at early stages. So in addition to data analytics, people are able to understand the industrial systems, and therefore they are able to go and create systems and learn and build the knowledge from the very early stages to create something which will be meaningful in the industrial ages itself. And I think that's how I would say the curricular gap between the industry and the education sector can be bridged by bringing in a collaborative model, by bringing in co-creation model, and by creating an ecosystem where the talent or the students in an early stages can go and look at those equipments which is not usually available easily, and they're able to understand that and create their products, and they're building knowledge on top of that from the very early stages. That is how I would put that perspective.
Thank you, Chandan. So that was really great, catching them early, as well as collaboration with different sets of orientation from the OT versus the IT, and then making sure that learning labs are created to assist the transition. Well said. So in the interest of time, the last question might be 2 or 3 sentences about the future, about the data-driven industries. Looking ahead, 5 to 10 years, how will data and AI reshape industries such as yours, which is energy, manufacturing, and utilities? And what's your vision for the future?
I think it's incorrect to say it's going to change in the next 5 to 10 years. Data and AI have already changed industries like energy, productions, manufacturing, utilities. We have got systems like APMs, which are already predicting, giving consumers or basically energy producers better insights into their systems, having lower downtimes. They are already having continuously streaming data, real-time data. Edge computing, digital twins are already there, and which is helping industries get more effective, get more efficient. I think we are also able to understand the fluctuations in the grids. We are able to understand how the weather patterns look like using AIs, and how this is going to impact, let's say, energy production in renewables and basically typical standard energy producing industries. How do the grid kind of becomes a little stabilized? Even if you look at if I call data and AI as a differentiator, right? It has already proved its mark in the existing times itself. The future will be going beyond the industry 4.0 itself. I think we are already in the stages where industry 4.0 is becoming obsolete in terms of, and AI is basically integrating strongly into renewable sources of energy, the battery optimizations, the storage, the grids. Even at manufacturing levels, we are talking about dark factories now, which are running by themselves, which are self-healing, which are basically not shutting down because of an error, but they are trying to figure out what is causing that thing and how it is getting better. Again, we're looking at the OT stage. A lot of cybersecurity things are getting involved. They're becoming more anomaly-based detection versus a rule-based. So I think industry has already evolved with the data and AI, and with the immense amount of data that's available for us to go and decipher, and with the advent of these AI systems and tools that are already there, the industry is already getting differentiated. And the organizations which are able to treat the data as an asset and not as an auxiliary component of their operations, they will be the ones, they will create value for their customers. They will have a very large competitive as against the organizations, and providing insights out of that for their customers, for their employees, for themselves.
Thank you. So not just there in the future, it's already occurring. That's what in simplicity you mean. And that With the future, it's going to be of a differentiated value rather than a norm, which is usage based. Well said, Chandan Vijay. Thank you for sharing your insights on data strategy, AI integration, and the future of data driven industries.
Pleasure talking to you, Satya. Really appreciate the time.
Yep. For our listeners, you can connect with Chandan on LinkedIn to follow his perspective on data, sustainability, and digital transformation. The data revolution is underway. An organization that treat data as a nuclear reactor than just an oil will lead their industries. Thank you all for listening.